My name's Silvas, I'm a software architect at GoDaddy, and this is Bulletproof Node. So you might recognize this piece of code here. It's used in a lot of demonstrations for good reasons. It's very simple. It's just a web server. Serves up on the LEAP port. Hello world to any response, no matter what the path is. If it looks familiar, it's because it's on nodejs.org. This will serve as a starting point for some of the demonstrations that I want to show you. But what's interesting about this particular code example is that we're already waiting to fail. Whether it's because our application errored, a deficiency with V8, we've come to expect various failures throughout time. And to get away from the mindset that everything always needs to be perfect and to move to a mindset of we expect failure, it's imminent, what do we do about it? So one of the proposed tools is this package called cluster service. And the idea around this service is to provide just some basic scaffolding, some basic support around your service that allow you to provide the extra resilience. So pull up a demonstration here. So this is the same code that you saw in the slide. We're going to go ahead and start this up. So this is what we might typically see if we are running our Node application. No surprise, it says hello world, no big deal. So we're going to go and do the same thing, but we're going to run it through the cluster service. And so one of the first things you might see, is that there's just color spewed all over your console. And there's good reason for that. We want to differentiate between the cluster service and your application, the standard output of your application. So a few things that jump out at you. One, it says it's running in local only mode, which I'll get to in a minute. We've also got this CLI, this command line interface that's attached out of the box. And this will allow us to communicate with our service. So I haven't written any code beyond what my application is doing. And the next thing you'll notice is that we're getting spammed with worker start, worker start, worker start. So right out of the box, what it's doing is it's detecting the number of cores available in the system, and it's spawning by default a worker for each of those cores. So we're going to go back to our hello world, and as you expect, it still serves up. So effectively, this is using the cluster capability of Node to distribute those requests. This gives us that immediately out of the box resilience with our service, so that if a worker were to fail, which we expect, right, just a matter of time, that it's okay. It will actually recover from it, right? So here we go. We can see that the worker had exited, restarted. Meanwhile, those other workers are still serving up those connections, so no problem. So really it's about having these workers that fail be restarted gracefully. We expect the failure, right? It's just a matter of time. Whatever component in our system might fail, it's just a matter of how do we handle it? What do we do then? Do we have try catches littered across our code? Or do we say, you know, it's okay to fail because it's not actually going to have a measurable impact in the resilience and uptime of our service? Additionally, leveraging all the cores in our system, it's not something that we do out of the box with our Node applications. So this affords us not just the resilience, but knowing that I didn't have to write any code to leverage all the cores. And we expect these sort of things with other frameworks. Why wouldn't we expect it with Node? And lastly, since the work is distributed, it's highly available. This is a good start. But what if the master process fails, right? The watchdog of the watchdog. Our servers are physically melting. What happens when these catastrophic events happen? What do we do now? So what is it that has allowed this cluster service to help us with those problems as well? Well, as you saw here at the top where it indicates we're running in local only mode, so I'm going to go ahead and exit. I'm now going to provide basically a secret key. Now I'm actually running the cluster service to where it too is listening on its own port to receive commands. This allows us to not only communicate directly via the CLI, but also via REST interface. And this, from the standpoint of monitoring our system, allows for a health check at the very simplest level. So we want to be able to, whether it's your network operations center that does the monitoring or some third-party service, I want to know not just that my service is kind of being responsible for itself and restarting itself, but also that if something outside of our control were to happen, the service is no longer available. Somebody did something that just caused the service to go down, or even the server goes down, that we just have that out-of-the-box solution that allows us to say, is this thing even running? So this allows us to execute in an RPC manner commands to our service. We can use the command line to issue these. So as an example, go ahead and say health. So it's actually, it's showing us what it's actually calling as well as returning the result. So this is something that I can do either from the command line for convenience, or I can actually hook into the, make the REST calls directly if I prefer. So if I have a monitoring solution in place, that would work out of the box. In addition, even though it is secured by some sort of secret password that you provide, ultimately you do control what's accessible. So whether it's in-proc CLI, local only REST calls, or remote, based on the relative risk level of what it is that you're protecting. So for instance, I don't want someone to be able to remotely shut down my service. That's obviously something you would lock down and say that's never permitted. So we've got a built-in CLI over REST. This is pretty cool in that we can not only talk to our service via the REST interface, but we have the convenience of the being able to attach to the background service, right? So in this particular case, we actually see our master running. Typically, this would be done as a background service and you would never see it. Instead, I just want to attach to it. So here it says, oh, the service is already running. I'm just going to attach to it. So we can do all the same things that we can do as if we were in the master mode, with the exception of anything that is expressly defined as only privileged for in-proc access. So you'll see from the help, we have a number of options available to us, which I'll get into shortly what all they are. So one example of a trivial thing that we take for granted with other more mature platforms is the ability to restart our service without any downtime. So we'll go ahead and just do a restart all. We don't see exactly what happened from here other than the response because it's attached. But here, if you were to look at the master, this is where anything in white here is just the standard out that was piped from our application, right? I haven't written any specialized code. I haven't written anything specific to cluster service at this point. And here we see that worker exited gracefully, the new process was forked, verified running, and it went back and forth until all of these processes were successfully restarted. So in case you missed it, we have 3 input mediums: improc CLI, REST API, and CLI over REST. So the improc CLI is useful for developers debugging when we just want to use it as a traditional Node app. We're not ready to take it to the operational level. The REST API is good for CI and CD purposes, and then the CLI over REST is effectively just the convenience layer for REST that allows us to do all those same operations, but more conveniently. And any custom commands that we define, these will also work over these same interfaces. So because of the way that cluster service separates out the process forking with the worker module loading, this allows us an interesting opportunity to where we can leverage that same restart of a worker, but to actually bring up new instances of modules in place of the old. So we can use that exact same sequence of events that I showed you with the restart, where we bring down a worker, bring up the new worker, but it's actually going to be loading a new module, whether it was a newly deployed module or an in-place upgrade, whatever the case might be. This allows us the opportunity to just, so we're still forking the original process, but we're invoking the different worker. So in this case, I pointed itself to the same existing server. So I'll go ahead and show new worker. Hello, new world. Yeah, very original, I know. New server. Go ahead, upgrade all of our worker processes using new worker. And so you can see the standard out is now pointing to the new server. And of course, if we were to go over to our application, it's now serving up the new worker process. So we're not only able to do no downtime restarts as we would expect from any mature service, but we can actually do these as upgrades as well. So that opens up a lot of interesting possibilities as far as deployments go. And we can, of course, do this via the CLI like any other operation. Now, what it does as far as the replacement goes is it'll bring up the newly forked process first. It'll verify that it's running, verify that it's healthy effectively before taking down the other process. And then it'll just do that back and forth until all processes are upgraded. And we can get an idea of what our system looks like. It gives us a glimpse into what processes are actually, what child processes are actually running, their PID, as well as the actual worker instance that we're pointing to. So in this case, for demonstration, I'll just do an upgrade of 3248 to the old worker. And so in this case, you can see that it outputted the old worker's response. So now if I pull up the listing, that old process is gone. We've now got 3 instances of new worker and 1 instance of the old worker. So that allows us effectively, if we had the need to try out stuff as a incremental deployment process or mixing, matching different worker types. So we get a lot of out-of-the-box commands. Start is effectively the ability to start workers after we've already run the master. So in this case, I can do start new worker.js. It'll start a new worker. Now we have 5 workers running. So those workers don't necessarily have to have the same goal, right? They can be completely different objectives. Some things might not be able to handle running multiple instances of. So maybe your application is not designed such to where it can support multiple running processes. They might conflict because of whatever they're integrating with causes, whether it's a race condition or a data inconsistency, whatever the case might be. We've got the restart, which I've showed, the upgrade, help, health, workers listing. You can also view the full worker dump if you're interested, but by default, it just gives you the simplistic view. Now, as far as the help goes, you can actually provide additional details. So if you want to know help about a particular command, you can do that as well. We also have custom commands, which opens up a lot of doors, right? So now we have the worker resilience, we have communication with our service. Now we want to add our application or service specific behaviors. A good example or a good use case of this would be, well, the health check out of the box just blindly says, I'm okay. It either works or it doesn't. But if we wanted to provide metrics around what healthy means, I could easily override that command and provide measurements of what the performance of the system is, whether or not the services that I depend on are running, and so we can actually fail gracefully as a result. So in this case, the command, a custom command is nothing more than just another module, a node module. And the first argument in the callback is just if an error occurred. In this case, I'm never going to respond with an error. The second argument is the response. In this case, it's a primitive type. It's a string. It can be anything. It's just an object. Anything that can be deserialized, serialized, piped over a REST interface, and deserialized is a valid data type. So in this case, I'm responding with an object that contains message, hello world. I'm also defining a couple other properties. I'm controlling the accessibility of my module, so I want to make sure that hello can never be executed remotely. I actually only want this to be either executed in proc or locally over the REST interface. And I also provided some help documentation for convenience. So in the future, you will also be able to leverage custom commands without actually writing any code associated with starting up the server. So in this case, I actually do manually register this hello command. You'll see C service on hello, and then this is the module that we were just looking at, this command hello. And much like the command line interface, it's doing a start, passing in the worker that I want to start, and the access key. So if they look very similar to the command line interface, it's because they are identical code that's being executed. So I'll show you what that looks like real quick. So in this case, I would just say node server.js. Identical resilience, identical features, everything else is the same except for I'm actually executing my server file instead of the command line interface. But we still have all the same capabilities as far as, right, I'm still attached, I can still restart, I can do all, all the same things that I did before. Except for now, if I were to do a help listing, I see my hello command, I can do help hello, I get that same data dump that was in that command, as well as I can, of course, execute it. So if I were to execute it here, I'd see, as I expect, the exact object that I had responded with. I could do the same thing here via the attached CLI. So here, it's identical result. So it's very straightforward, creating our own commands. Creating our own commands versus overriding our commands work identical. So if instead of hello, I overrode health, right? It would work seamlessly. Another use case for writing code specific to the cluster service is in the case of lazy workers. So this is where we need a more concrete and established relationship between our master and our child worker processes. So everything we do in Node typically nowadays is asynchronous, right? So saying that the service is available because the worker process started successfully, that's not necessarily the only metric for availability. So in this case, a binding of HTTP is technically an asynchronous task. So the service may not actually be available just yet. So what we'll do to demonstrate that is we'll go to our new worker. We won't mess with our old. And I'll just say require cluster service worker ready. So what we're saying is on the callback for the listener, once it's actually listening, then report back to the master that it is actually available and running. So I'll go ahead and do an upgrade all, new worker.js. Okay, so now it's actually running that new code. But I'm going to make one other change that was indicated here. And that at the bottom, we don't actually know what the relationship between the master and child is yet. So we need to explicitly call out that the worker that we're going to be running is not ready by default. So we're going to new worker. So we're going to indicate that this is not actually ready by default. So if we were to do a restart all, the difference here is that the verification process is based on that callback event now, rather than the worker process simply running is no longer the success criteria. That's part of it, but the final success criteria is actually waiting for that callback event to the master process. So to better illustrate that, let's do something a little different. So we'll get some horrendous delay here. Looks about right. Nope. All right, looks about right. So let's try this. I'm just going to restart. All right, so the event's not being received because we're not actually invoking it, right? It's always wonderful to have bugs in your live demo. It's not a demo otherwise, right? All right. That looks a little bit better. So in this case, we'll do a restart all. So you see that delay, so you know that it's waiting for that signal event. We'll go ahead and reduce that delay one last time. Now we see that it's a lot faster. Okay, get the point there. So now we have that relationship between the master and child. We've really only written one line of code to achieve that extra relationship, which is completely optional, depends on your use case. Some additional things that I want to call out, we're running out of time. I want to get to some Q&A, but we can pass in configuration data. So instead of using very verbose a number of parameters. We can just pass in a JSON file, which will act as our configuration. We can control the number of workers by explicitly calling out that I don't want to use the default based on the number of cores detected. I want to use a specific number of workers. We can issue run commands. It does a little bit of detection as far as the extension passed in. So JSON is detected for JSON configurations. If you're not using that extension, you would pass in the config option instead. JS extension is detected if it's actually the worker itself. Otherwise, it executes it as a command. And you can explicitly call out run if you so choose. Lastly, you can define sets of workers. So if you have different roles within your service, not just a single worker, you have that option as well. And you can explicitly call out the number of workers that you want to actually run as. So we have little to no code required to auto restart or failed worker processes, leverage all of our cores, remote control, many out-of-the-box commands. We can create our own commands, customize privileges, and we have asynchronous workers. Ultimately, it's about having a peace of mind with our service and bringing it up a notch with little to no effort. Quick call out, we've got a number of Node projects, open source Node projects at GoDaddy, as well as a plethora of non-Node projects. But I want to make sure that the community is aware of cluster service, starts contributing. It's a relatively new service. There's a ton of opportunity to contribute in some form or fashion if you're interested. And lastly, we're hiring, so if you're a Node engineer and interested, reach out to us. With that, any questions?